Pythagorean Theorem. Alright? A squared plus B squared equals C squared. Now, it's saying the sum of the square sides is going to equal the length of the hypotenuse square. Now, all these together, both sides equaling each other, that means that we're going to have a right triangle. Alright? So we're looking at this board, looking at this picture. The triangle is broken up into two different types of terms, right? What are those two terms?
LEG and height.
What does that stand for? Where you put the
leg.
Leg and hypotenuse.
Oh,
LEG. Leg and hypotenuse. Now, to put this in some more of a better frame of reference, if I wanted to just use these parts, how would I write the Pythagorean theorem using just the parts of the triangle?
leg plus
Leg plus square plus leg.
leg plus leg.
What has to happen with these sides though?
Leg equals
They have to be what?
Squared.
Squared. So, what would it be?
leg
Leg
square
squared
plus
plus
leg
leg
square.
squared equals hypotenuse squared.
Where's my pencil?
Alright, now before we actually got into this, what did I say about the hypotenuse? C. What did I tell y'all about C?
It's the
height,
longest.
It's the height.
It's the longest side, right? So we're looking at something but it's hard for me to kind of tell that the side is the longest. Like what if we had equal distance legs or and the hypotenuse? How would I be able to tell that this is the hypotenuse?
Because it's C.
Because it's
the-
longer.
What
It's
if
a
you couldn't
longer
tell-
word.
What if you couldn't tell which is longer?
It's the
It's
longest
the
word.
slanted one.
And
Depending on how you turn, they all slanted.
Well,
C is longer than B.
How can you
C.
tell that though? What if
Because
it
the
looks-
word's long.
What you got?
If you straighten them out, then you don't.
You can't straighten them out. They all look the same. How would I be able to tell?
Turn it
Just
all
by looking at
down.
this. Look
Oh,
at
by
picture.
the square. The actual
Cut it in
square
half.
box. It doesn't have a square. It's not right. It's not right. Anyway.
where it makes the angles.
But that means C
Wait, the
is
side that doesn't meet the
which
angle.
is less than 90.
Sum it up.
I'm confused.
The angles to
Keep watching.
The hypotenuse is going to be directly across from the right angle. You take your finger and put it on the right angle and slide it to the other side of the triangle. That's going to be your hypotenuse.
Oh my God.
That's how you can determine where the hypotenuse is. So even if all sides look the same, it does not matter. If you know where the right angle is, you can find the hypotenuse. Now, we can use this particular theorem for two things. One, to determine whether or not, or what we're going to use it for, is to determine whether or not a triangle is a right triangle. And then what if I want to find the side? I got two of them, but I'm missing one. So I need to find the third. Those are the two things we're going to do. All right? So, first go around. Here's the question. Is this going to be a right triangle?
Yes.
Y'all don't know. How do you know?
Because the
Because it has a box.
I mean, if you look at it, like,
it's
Pretty much.
facing the wrong way.
No, it's
It does. It matters. It matters.
It matters.
It matters.
It does matter.
Joe.
It really does.
Oh.
9, 10, 8.
Is it
It's
a right triangle? How do you know? What are you going to have to do in order to figure that out? What are you going to have to do in order to figure that out?
There's a right angle.
There's a right
What does that mean?
the
How would you know it's a right angle? It's a
angle.
little.
90 degrees.
How?
The box.
because it's
You
right
see a box up there?
No.
So because there is no box, how can you tell that it's a right angle?
It's across
not.
from
It's
the.
like
What's that mean?
It's across
It could be 89 degrees. It could be 91
Because
degrees.
it's right across from the hypotenuse.
It's
Yeah, it's
We're
right.
not definite. The thing is, figure out how. What
9
have we
times
been?
8. I don't know. We're just
Oh,
trying to
I
obvious
have
stuff
no
here.
idea.
Stop
Oh, 10
talking.
times 9.
Stop. On your paper, figure out if it's a right triangle. What are we using to determine if it's a right triangle?
legs.
This.
Hypotenuse.
Do it. Do it. Do it. So for it to happen, for it to be a right triangle, what has to happen?
You have to identify.
It has to have
You have to
it
put
has
it-
to have a hypotenuse.
Put the equation. What is in the middle of the equation?
Eight.
Leg.
This is one symbol. What is that symbol?
Plus.
Nope. Equals. Equals. That means one side of this equation has to equal the other side of the equation. So the sum of the square of the sides, those legs, has to equal the distance of the hypotenuse square. So however long those two legs are and you square it, then you add them together, should equal the length of the hypotenuse and then it's squared. Again, that's what the equal sign means. Both sides equal each other, right? So how would I apply that to this triangle? What's the first thing I'm going to figure out?
You'd have to
Before I even start filling stuff in, what do I need to know?
the legs, the hypotenuse, and legs. A, B,
So what's that?
9,
9.
or A.
What's the only thing I really need to know when I'm doing this as of this moment?
Hypotenuse.
I need to know C, right?
Yeah.
A and B are interchangeable because they're both what?
They're-
They're legs. The only thing I need to know is the other side of that equation, which is what? C, right? So, A can be 9, B can be what?
8.
C is going to be what?
10.
10, cool. So what is the thing that we're going to use to figure this out?
A squared plus B squared equals C squared.
Cool. So start off. So that's the second thing we need to take care of. First, figure out what you're going to, or what's what. What is A, what is B, what is C? Second, figure what's in there. Or whatever the vehicle we're going to use to figure this out. So in this case, we use the Pythagorean Theorem. A squared, B squared, C squared. So now, fill in the blanks. So what's A?
9.
So it's 9 squared plus 8 equals
10 squares.
10 squared. Alright? I'm using these parentheses to show, hey, only thing that's changing is what A, B, and C are. Everything else stays the same. The squares don't go away, the plus sign don't go away, the equal sign doesn't go away. The only thing that changes is me substituting in A, B, and C. Alright, so now, what's 9 squared?
81
81
plus 60.
plus 64 equals 100. Cool. Last little thing. What's that left side equal to?
145.
145. So here's my question. What is this information telling me? Why is it not a right angle? Right triangle?
Because they don't equal.
Both sides don't equal, right? One side is bigger than the other. Well, if that's the case, then what kind of triangle is this?
We don't have not a right triangle.
Alright. Who remembers the three different kinds of triangles, just off the top? The basic three types.
Right, acute,
You
and
got right, what else?
Acute.
Acute,
Obtuse.
and obtuse, right? Cool. Let's look at these, though. Figure out what they look like. So, we all know what a right triangle looks like. It's got the box, right?
Yep.
What is the formula, what is the theorem we use? How can we determine if it's a right triangle?
The box.
If I knew the sides, how would I be able to say?
It's shaped like an L.
If I knew the measure of the sides of the triangle,
And it goes up to
how can I
It goes up
use
to that.
those sides to find or justify that this is a right triangle?
Measuring the hypotenuse measuring was equals.
We just got through talking about people. We ain't even talking about angles. If I said
Let's be
sides,
equal.
cross.
Let's be equal. The sum has to equal in degrees.
if I said anything about degrees, I said it's a right triangle. So we're looking at what was the only way we've been talking about triangle? Using their what?
Box.
That's called a what? It starts with an S. You get it? Fries, mashed potatoes, baked beans, sides. So we're going to be looking at the sides, right? So what in this room that's on this board that we justified and used to say that this triangle is a right triangle?
Pythagorean Theorem.
Which says what?
Determines whether a triangle is a right triangle.
A squared plus B squared, what? Equals
C
C. So if it equals both sides, one side equals the other, then we have a what kind of triangle?
Right triangle.
Right triangle. In order for a triangle to be right, at least one of the angles has to be 90 degrees. In order for a triangle to be obtuse, what has to happen?
Over 90, under 80.
What? Not degrees. What has to be done? I need to have one angle. I can't have more than one angle inside of a triangle that's bigger than 90 degrees. Because if I add up the three angles inside of the triangle, it's going to equal up to what? Yes, 180 degrees. That's going to be considered a what kind of triangle? Acute. What does an acute triangle look like? Well, how would you just describe it?
One degree under.
All three angles are going to be less than 90 degrees, right? Cool. So now, I'm trying to figure out a way to use the Pythagorean Theorem to kind of say, or if I work a problem out, I can tell whether this is an obtuse or an acute triangle. Now, if I'm looking at the obtuse type of triangle, what tends to be the complete What is the abnormality in this? What is a little bit bigger than what it's usually going to be? The hypotenuse. Stretched out. So what ended up being longer than what we were going to be if it was a right angle? The hypotenuse would be stretched out, right? If the angle was smaller than 90 degrees, what shrunk? The hypotenuse shrunk. So, on one hand, the hypotenuse got extremely long. On the other hand, the hypotenuse got smaller. Is that what we're looking at, correct?
Yes.
So if I want to apply the same kind of method, we've already used equal. What two other signs do I have left?
Greater than or less than.
Greater than or less than. Cool.
Trying to trick you.
So here's my question to you. Which goes where? Think about it. Think about it, because I'm going to ask you why.
Press pause.
Who can tell me which goes where and why? And why? Trent, I'm going to read this.
Because the rectangle, it'll be like smaller than the vertical hypotenuse. Since the A and B, it'll be smaller than the hypotenuse. So then it would be less than, wouldn't it? Because it's going to be smaller.
What's going to be smaller than that?
The A squared and B squared.
So that means the who?
The hypotenuse will be bigger.
So you're saying in a acute triangle, the hypotenuse is going to be bigger than the sum of the square legs, right? Is that what you're saying?
Yes.
All right, anybody else got anything? For which triangle? All right, so we got one that said the legs are going to be bigger, the other said that the hypotenuse is going to be bigger. If I'm looking at this picture, which would suggest that the leg side of this problem, or this equation, would be bigger than the hypotenuse side? Cute. Which would suggest that the hypotenuse side is going to be greater than the leg side. Obtuse. Because keep in mind, we're squaring these. So if the hypotenuse is already an abnormal, a bigger size, a bigger length, then you turn around and square it, what happens? It gets even bigger. Alright? Versus if you got a hypotenuse and it's small, then you turn around and square it again, is it really going to be bigger than adding two numbers that you squared? Not necessarily. Just case in point. What happened? What did we end up getting?
145 equals 100.
So we end up being what? 145, what?
Equals 100.
But did it equal 100? Which side was bigger?
Greater than 100.
It was 145 is greater than 100, right? So that means this is what kind of a triangle? It's a cube. Because the leg side is bigger than the hypotenuse. Let's try this one.